Hello, good morning. So today we will get into the another topic of permeability. The main topic which we are going to cover are we'll see what is meant by Darcy's law, law which governs flow of water through the soil. We'll see what is meant by discharge, though it is commonly known to us what is meant by discharge, but we'll get into it little bit so that we have our clear ideas. We'll see what is meant by seepage, and lastly, we'll see derive a equation which governs flow of water through it. This equation is called as Laplace equation. So in all, four topics will be discussed. So let us see one by one. We know soil is nothing but a collection of solid particles wherein there are gaps in between these solid particles which are called as voids. These voids are often filled with water or air, or water and air both. Thus for us, soil is nothing but a porous material. However, when these gaps in between solid particles get interconnected with each other, they form a pipe-like structure. These pipe-like structures allows flow of water through it. These particular property of soil which allows flow of water through it is called as permeability. Thus, permeability is nothing but the ease at which water can flow through soil or rock mass. This movement of water is possible through soil only if certain amount of energy is available for that water to flow, and this has been put forward by a scientist called as Bernoulli. The energy could be a combination or it could be because of the single source. Now the total energy which could be available to this water for flow could be because of velocity, it could be because of elevation, or it could be because of the pressure which is present there. These are often terms, these energy is often termed as head also. So the total energy available could be a combination of velocity energy, potential energy, and pressure energy. This is put forward in the form of equation H is equals to V square upon 2G plus Z plus P upon rho G, where H is total hydraulic head, V is velocity, G is gravitational constant, Z is the elevation about atom, P is pressure, and rho is fluid density. Once we know this, that flow of water is possible through the soil, let's see what governs this flow of when governs this flow of water through the soil. Yes, water flow is possible because of the available energy, but once it starts moving, how it moves and what things govern that flow when this flow is happening through the soil, that is called as Darcy's law. The law which governs flow of water through the soil is called as Darcy's law. The flow is often measured in terms of velocity, which we call it as V. Now, the velocity with which water will flow through these soil sample will be directly proportional to the head or elevation head which is available there, and it will be inversely proportional to the length of travel. So V will be inversely proportional to the length of travel L, and V will be directly proportional to the elevation head. That means difference in elevation between the two levels which makes the water movement possible. When we put these together, we get an equation V is proportional to H by L. When we take out this proportionality constant, we could express it in terms of V is equals to K into H by L, or could also write it in terms of V is equals to K into I, where V is velocity, K is coefficient of permeability, I and I is hydraulic gradient. This is called as Darcy's law, where K is constant of proportionality and it is called as coefficient of permeability expressed in centimeter per second. V is discharge velocity, which is expressed in centimeter per second, and I is hydraulic gradient, H by L. Hydraulic gradient means you can also call it as a slope which is available for the flow of water, and that is nothing but a ratio of head or elevation which is available divided by the length of travel of the water through the soil sample. If this is Darcy's law for us, V is equals to K into I. Let us see what is meant by discharge. So Darcy's law states that for laminar flow through an homogeneous soil, the velocity of flow is directly proportional to hydraulic gradient. Velocity of flow is also known as discharge velocity or superficial velocity. Coefficient of permeability is defined as the velocity of flow which would occur under a unit hydraulic gradient. Means coefficient of permeability is nothing but a velocity. The only thing is that at that particular instance, the hydraulic gradient should be equals to 1. That means h, small h, should be equals to length of travel of the water. Unit of coefficient of permeability is centimeter per second and it is equal to that of the velocity, and the dimensions are expressed in terms of L by T. We'll see now what is meant by discharge. Discharge is only possible or when water is having certain amount of energy. Here in this particular example, we can see a water tank resting over the roof. Now, velocity or flow is possible because of the elevation which is available here, and water is going to flow through under the gravity. Let us say water starts flowing, we open the tap and water starts flowing into a container, and we collect certain amount of water inside the container. The quantity of water which is getting collected is, let us say, 200 ml in a particular amount of time, that is 10 seconds. Then discharge capital Q will be equals to 200 ml, that means the quantity of water which has got collected, and unit discharge will be equals to capital Q upon small t, that means the quantity of water which has collected divided by the time in which that water got collected. That will be called as unit discharge. So overall, discharge could be expressed as Q is equals to V into A, where V is the velocity with which water is flowing out through the tap and A is the cross-sectional area of the tap. Now we move towards a phenomena which is called as seepage. We know seepage is nothing but a flow of water through the porous or in fact permeable medium. Let us say there is an impervious soil strata wherein we are having two canals, one on the upper side and another on the downward side, and these upward side canal is having a total head of HA, whereas the downstream side canal is having a head of HB. Thus, the elevation head or the head which is available to the flow of water is HA minus HB. Now, let us say if there exists a porous or permeable media in between these two canals, like this, or a pervious soil which allows the flow of water through it. That means in fact a permeable soil like a sand. Then water will start moving from this upper canal through this porous soil into the lower canal. or lower still canal. And this flow of water under gravitational force through the permeable soil is termed as seepage. This seepage could be further expressed. Let us say there are water molecules resting at the bottom of the canal. Now, once the head is available or energy is available to the flow to these water molecules, they will start flowing from upper side to lower side. Now, this flow of water could be well traced by the path taken by these water molecules. These paths taken by these water molecules are called as streamlines. These are called as streamlines. And the amount of energy which got dissipated during these travel of water molecules could be traced, and the points having equal amount of energy could be joined together by using a line. This line which joins a point on the travel path of water molecule such that the water molecules will have same amount of energy at that particular time instance. These lines could be drawn, and these lines are called as equipotential line psi, suggesting that the potential which is present at that particular time instance and that position is equal, and that is why it is called as equipotential line. The diagram which gets forms when we draw the flow path of a water molecule, that means streamline, and the points or lines which joins the points at particular time instance having same amount of energy, that is equipotential line, we get a diagram. That diagram is called as flow net. We'll further explore it when we'll take it in detail, but as of now this is what happens, or this is the uh, form of representation of the seepage phenomena, and we call it as flow net.